noticed how some things, they seem really complex at first,
Right.
but then once you sort of get the underlying idea,
Yeah.
it's like,
Uh,
oh, okay, I get it now.
I thought
It's
it.
not that complicated.
Yeah.
Well, that's kind of what we're diving into today.
Okay.
We're looking at Professor Emily Riehl's vision for doing that with
Okay.
some really, really advanced math,
All right.
infinity categories.
Yes. And the source for our deep dive today is Professor Riehl's article, How to Teach Infinity Categories to Undergraduates.
Okay.
And it's a pretty radical proposal.
Yeah.
She's basically arguing for like a fundamental shift in how we approach teaching math,
Wow.
with the goal of making these very, very sophisticated structures accessible way earlier in the education process.
Okay, so let's break this down.
Yeah.
So this dream, as Professor Riehl calls it, is to take something as advanced as infinity category theory
Right.
and integrate it into the standard undergrad curriculum.
Exactly.
Like the same way we teach abstract algebra now.
Yeah, like it's just a normal part of the undergrad math experience.
So what I find really fascinating here is her belief that homotopy type theory, or HOTT,
Right.
can make these ideas actually intuitive.
Yeah, and this is where I think it gets really interesting because there are historical parallels to this.
Okay?
Think about Everest Galois
Okay.
back in the day and his work on Galois theory.
Mm-hmm.
I mean, those concepts were so abstract.
Yeah.
At the time, people didn't really get it.
Right.
But those ideas became like the foundation for modern algebra.
Wow.
And the point here, and this is what Professor Riehl is pointing to, is that
Yeah.
sometimes when you take a more abstract perspective,
Mm-hmm.
it's not about making things harder.
Right.
It's about providing a more powerful lens for understanding things better in the future.
Right. It's like giving you a better set of tools.
Exactly.
Yeah.
And this could completely change how mathematicians approach and solve problems.
I love that.
Yeah.
So, okay, for those of us who might not be super familiar with this, what exactly is category theory?
Okay, so category theory, you can think of it as like a way of seeing the common structures across different areas of math.
Okay.
It's like having a bird's eye view
Yep.
that lets you see these underlying similarities.
Okay.
For example, the idea of like reversing a process.
Okay.
You see that in set theory with inverse images.
Huh.
You see it in linear algebra with tensor products.
Right.
And you see it in abstract algebra with free groups.
Got it.
So category theory gives us like a language to talk about those shared structures.
So it's like finding the common DNA between
Exactly.
seemingly different mathematical concepts?
Yeah.
And so what's the advantage of having this abstract viewpoint?
Well, one of the biggest advantages is it allows you to unify results.
Okay.
That might seem totally different.
Okay.
So instead of having like separate proofs for similar ideas in different areas,
Hmm.
you can use category theory to prove a single theorem.
Wow.
That applies across the board.
That's pretty powerful.
It is. It's very powerful.
Yeah.
And it really streamlines our understanding.
Okay, so we have category theory as this like unifying framework.
Right.
Now, what are infinity categories?
So think of regular categories
Oh, yeah.
as showing like simple relationships between objects.
Okay.
Infinity categories are like that, but they include relationships between relationships
Whoa.
and relationships between those relationships and so on.
Okay, so it's like
It's like layers of detail and
it's
connection.
one of layers.
Yeah, exactly.
Okay, so it sounds like it could get complicated quickly.
Yeah, it can.
So how does HOTT help us here?
Well, Professor Riehl argues that homotopy type theory
Right.
provides like a new language, a new
Mhm.
way of thinking about these higher dimensional structures
Okay.
in infinity categories.
Mhm.
And this new language potentially makes these concepts more intuitive.
More intuitive.
Yeah, more natural.
Wow.
Yeah.
So if this all works out,
Yeah.
what's the big takeaway for like you and me?
Well, I think Professor Riehl is suggesting a potentially huge shift in math education.
Oh,
But
got it.
embracing this higher level of abstraction earlier on,
Mhm.
and by using tools like HOTT,
Yeah.
we could make these super sophisticated ideas like infinity categories
Yeah.
understandable way sooner.
It makes you wonder if this could be like a turning point,
Right.
similar to when abstract algebra became a standard part of the curriculum.
Absolutely.
So to sum up,
Yeah.
Professor Riehl is proposing that by looking at the most fundamental structures, we can actually simplify and make advanced mathematical ideas more accessible.
Yeah, and I think that raises a really interesting question.
What's that?
How often in any field of knowledge does a move towards greater abstraction
Yeah,
ultimately lead to a clearer and more powerful understanding?
that's a really good question.
Like, is this a fundamental pattern in how we learn and progress?
Definitely something to think about.
Yeah.
And if you're interested in learning more about Professor Reel's ideas,
Hmm.
we have a link to the full discussion waiting for you.
Awesome.
Thanks for diving deep with us today.
Of course, my pleasure. Yeah,
Take care.
you too.